starting from history of cement and manufacturing process and what are tests we are going to do. Then we cover a little bit touch on role of cement and role of concrete in this topic. There is a 45 slides, but try to cover it as quick as possible. I think I'll not bore you too much. Just a minute, share my screen. Hello. Yeah, thank you. So today we're going to discuss on the role of cement in concrete. So before that, we should understand how what is a cement, so that we'll touch upon few slides on cement. Cement in the history we have covered in 1796, Roman cement is patented by Joseph Parker, and 1811, British cement developed by James Forrest, and 1812, hydraulic binder. Sir, there is some noise. I think others you can unmute yourself. Mute yourself.
Someone Vivo V2335. Kindly switch. Vivo V2335. Someone is.
Yeah. So in 1812, hydraulic binders. Yeah, 1812 hydraulic binders research conducted by Louis Wickett. I think we used to use cement testing Wickett apparatus. I think it is a person invented for this Wickett apparatus, maybe. And 1824 innovation of Portland cement patented by Joseph Aspden. He is the first person for innovation of invented for cement for in 1824. Till that time, we were used various form of binder in various material across the world. But till 1824, first person to introduce for cement in Joseph Aspden. And after that, 1838, innovation of chemical engineers process for Isaac Johnson. And 1846 commercialized Portland cement. Till the time, it is a trade secret, or maybe may not be trade. It's a secret for with some kingdom only. After that, is son of Joseph Aspden. Is a William Aspden is away from this country, and he came to some other location. Then he is established and commercialized for common public also. Till that time, he is only used for kings only. They can use only for king construction, maybe the fort construction. Till that time, not given for common public. So 1846, the first cement is commercialized and sold in the market for the common public also. Just a minute. Underloading. Hello. So then 1875, the formulation of standard. Till that time, almost 30 years, there is no standard for this standardization for the cement manufacturing process. Right? So 1875, first formulation for on cement, because till that time they were all the different companies, different countries, they were still maintaining some different standards. So till 1875, the people are not following proper cement. This is cement, this is a standard. So standards developed almost 1875 only. Till the time, there is no proper color, there is no proper setting, proper strength, there is no uniformity. So after 1875, the formulation for the cement, they made some standardization for the setting time, maybe strength, everything. They made a color, everything made some standardization. After that, 1830, there is they used for vertical clean. Again, 1885, the rotary clean, this is a wet process. Then 1930, a long rotary clean is a wet process. Till that time, wet process only. Again, 1970 is a real change what we are cement personally we are getting. This really changed, or maybe overall process changed in 1970 only, because start rotary clean and preheater were introduced in preheater in dry process. Till that time, they were used to maybe wet process, semi-wet process, or dry process. In preheater introduced in 19th, and I'll tell you what is the advantage of preheater later slides, upcoming slides. So before that, we used to see this process and develop technology for development on cement manufacturing process. In 90s, they were used wet process, long rotary clean with clean inside clean, improve the heat exchange. Then after that, almost 1950, in the 19th century, they introduced semi-dry process, and 1980 they were gone for a semi-wet process. So after that, then dry process are introduced, and then convert to long rotary to short rotary, and also they introduced the preheater. The preheater in 1970, and at that time they used for 3 to 6 preheater before burning of any raw materials. If you take an example, if you 100%, it's a wet condition. If you burn any material to drying, require more amount of energy. To optimize the energy, they were used the preheater. Now, even if you take an example of a washing machine, semi-automated, automated. Nowadays, we all are using automated washing machine. Whereas semi-automated, one side is they will one side the washing, then drying process later do, and before drying a cloths. Likewise, they introduce in cement also, before burning or drying of raw materials, they preheated. They heat step by step. They heat on the process on the material. Then the coal and energy cost were reduced because of preheat technology. They are drastically reduced on cost and efficiency. Right, the simple process, normally we take limestone from mining and crushing of limestone, and again mixing of clay or bauxite, and further grinding and clean operation is the burning of limestone, almost 1500 degrees Celsius of limestone. Then after that is called as a clay, this called as a clinker. Then clinker with the gypsum, further grinding, it's a called ordinary Portland cement, or clinker gypsum fly is called Portland cement. Clinker gypsum slag, it's called Portland slag cement. After grinding, then you go for the packing, distribution, maybe bulk or a bag, whatever the mode of required. Then we transport packing, then distribute maybe road and rail, or maybe ship. This is the process, simple process, cement manufacturing process. I'll take you through simple steps how the cement is manufacturing. I think for academic purpose, for everyone maybe recollecting, I'm just giving this input on how the cement is manufactured. So limestone we are taking from maybe from quarry, then transport mode of maybe conveyor belt, or maybe dumper, or maybe trucks, whatever the mode of locally available, depends upon the factory to mining. Will they'll take the different modes. It's factory, quarry to factory, factory to lorry. These are simple concept of cement manufacturing process. So after that, dumper come to, reach to the plant. Then it goes to the primary crushers. What are the big size of boulder reach to the plant? From there, we reduce the size of boulders like limestone. It's limestone, nothing but dolomite rocks. Further, we are storing at some storage place. Further, again, we are whatever the storage of limestone. Further grinding with maybe clay or bauxite with a raw mill. After powderization, then we'll feed into the just feed into the preheaters. Whatever the raw material, this top, it is raw material feed into top, and wherever the clean operation where there is a burning of coal or maybe alternate fuel, it's a temperature around 1500 Celsius. Whenever anything you burn, there is a heat gases will come. So heat gases collected and feed it to the bottom of preheater. Then it reaches to step by step. Then it, after drying, then it reaches to the clean. The clean is completely burning. It's limestone become lava. If you imagine any material, if you burn it's more than 1000 degrees Celsius, it must be become a liquefaction. It's like a liquid shape. So it is completely burned. It will completely burn. Clinker called after some time cooled. It's called clinker. So after clinker storage, the further further we are mixing gypsum or clinker, further grinding with the ball mill, or we are crushing the powder form, then packed into the market. So what is the purpose of remixing gypsum? Is the controlling of setting time, not somebody said that it is retarder. It is set retarder. It is mainly for controlling setting. That is the purpose of we are mixing gypsum in cement. It may be 3 to 5% of clinker, 3% gypsum added in the overall percentage of clinker. Right, this is a simple process. Cement manufacturing. This is the ball mill. Inside, I think you all would have tested in concrete jelly, maybe coarse aggregate abrasion test, Los Angeles abrasion test. You imagine it's a big size, diameter almost 3 to 4 meter dia size. The tube around the length will be around 6 to 8 meter. Like that, it is rotating with the balls, then crushing the powder form. Then powder form, it's screening, maybe sieving. Then further, whatever the more final material that goes to the silo, then silo to pack in cement to dispatch in the market. This is the way we used to do, which I want to emphasize on the importance of preheater. See, if you take this is the preheater which I told you in the beginning, few slides before. Just imagine this is the preheater. Sorry. So this is the preheater. This is the preheater. I'm just taking for few next few slides. So this preheater, what they will do. So this preheater, here we are burning of limestone. Here we are whatever the burning of coal. The whatever the heat gases collected from here to it reach whatever the red color mark. It is from bottom to go top of the preheater. Again, wherever the green color, this is the green color. From here, we feed it to raw material from top to bottom. So raw material feed it to top to bottom, whereas heat gases goes from bottom to top. It's opposite directions. So because of that, heat gases produce induced in the bottom. Then the step by step. The raw material, whatever the wet condition is dried. So before burning, this help to drastically help the coal cost, maybe or energy cost. See here, in the preheater, it's for 300 degrees Celsius to almost 900 degrees Celsius heat are in the process in the raw material. Then after that, then feed into the clinker, clean is almost 1000 to 1500 degrees Celsius. On coal, if you completely burn, it's like a liquid stage. After some time, you spray water slowly, then it cool down the raw material, clinker. So because of that, it's formed as a clinker. The clinker is the raw material. The based on the clinker gypsum, we can add secondary material for the cementitious material. We can based on secondary material mineral admixtures. It will change the type of cement. If you add fly ash, it is a ordinary Portland Porcelain cement. You add slag, it will Portland slag cement. Such a way that the cement type is changing. If you take OPC, it's ordinary Portland cement, it's clinker and gypsum only. In nowadays in the market, you almost find a 90% blended cement. Blended is nothing but something is blending with the cement, that is called blended cement. It may be slag or maybe fly ash. I don't want to go in detail in a clean operation. See, this is the entire process in cement manufacture plus controlled by central CCR team, central monitoring team. If any process, this is the I said this is a place called preheater, and this is a place called clean operation. Entire thing is controlled by a monitor only. If there is any issues in this feeding or RPM or maybe feeding rate, everything is indicated in the screen. That means and nowadays all these cement plants are made rather than mechanical, all like almost is central processing the controlled by in monitor itself. So whatever is the rate of feed, even rate of feeding, every rate of rotation, everything is it will monitor the system. Why? Because cement should be uniform. If it start from beginning from day one to maybe morning, if you take an example, 9 o'clock one shift start, morning shift to next day morning 7 o'clock, the same system is followed, because then only you will get a uniformity of cement process. That is the reason everything is controlled in the screen itself. If there is any issue, then you immediately stop. Then somebody go there, rectify it, again further start the process. So that now the entire cement manufacturing is computerized in closed circuit. There is no open circuit today. No closed circuit. Entire cement manufacturing process are closed circuit. Once feed the limestone, you will get a cement. So this is the process. Nowhere you can see the visible process. So we are all completely fully closed circuit only. right? So raw material we are using calcareous metal, nothing but is limestone, and alloys metal, nothing but containing clay matter or maybe iron oxide, bauxite we are using. And our factory we are limestone, iron ore or bauxite we are using for calcareous metal, and fuel maybe coal or petcoke. These are the material we are using our factory for making cement manufacture entire process. And I think you must be knowing that there are many testing procedure on cement. Not only the instead setting a financial time. Nowadays, all are made advanced equipments on cement monitoring mechanism. But not only for wicket apparatus. This is a normal used to do for normal basics. Apart from that, microscope and particle size analyzer, chemical testing, and extrafluorous, everything we are using at the plant, and monitoring it test, because those days if anything happen, so anything happen those days for a human, they'll go for doctor, then test for the only blood sample. But nowadays, if anything happen, they do ultra scan, CT scan, all scan happening, because they want to detect what is the problem in human body. Like such a way that even cement also, just we give the cement sample, feed it to the pallet, just scanning, and the instant fraction of second will get this all this information within fraction of second information. And parallelly, we used to do physical also. We never know anything happen is mechanism also. So what we do normally, we do it in mechanical, sorry, physical also for the chemical test, and also mechanical test with the mechanical. And we fast analyze we do for faster analysis also. Why? Because we want to check both the cases. If there is any deviation, we do further redo the process for testing analysis. This is the process we adapt all our plant across in India. We have 46 plants in India. All the plants we are introduced such mechanism. And also this which we are told central control room, which is already I showed these images. Even a few of the few of the plants we were introduced robotic testing machine also. Why? Because sometimes you never know human error. These are robotic machine, few of the plants introduced in the new plants. These also are available for testing our quality. And few of the companies also introduce the same technology for testing procedures. So this is the, I told you that total control vein mechanism. So this is what I said, cement manufacturing process, from you are taking lorry, from quarry to lorry, a lorry from you are crushing the raw material, and blending of maybe clay or bauxite with lime, and further grinding, and again rotary clean operation, that is called burning of limestone and iron oxide, iron ore, or maybe with clay. Then after that, after clinkerization, then we'll go for grinding with gypsum or fly ash. Then further we feed it to silo to then packing and dispatching the market. This is a simple process, cement manufacturing process. There are 7 stages simply, but each stage we used to check various quality checks. You imagine we used to get cement quality checks only for maybe 16 or 17 checks, because before cement itself we used to check each stage by stage. There are 97 checks we'll do normally quality process on cement manufacturing. There are even we do more than 100, but I'm just basics we'll do for 97 checks for assess the quality of raw material. First, that whenever taking limestone crushing, that we used to check whether the cement with the lime we can make a cement or not. So that we can check the 24 checks. Based on the limestone, then we based on the chemical composition. Further, we add iron ore or clay for further modification percentage we mix. After blending clay and limestone, all combination we out is how many 10 checks. Total this almost 34 checks completed before clinkerization. Then after burning of clinker, limestone, before making cement, we used to check 36 checks. Based on these clinker factors, clinker properties, characteristics, we'll mix fineness, what is the percentage of fineness, what is the percentage, what is the amount of fineness we need to keep, what is the percentage of fly ash we need to add, what is the percentage of slag we need to add, what is the percentage of gypsum need to add. Then further, we'll based on the test, we'll analyze. After this, then we mixed gypsum, maybe fly ash or slag. Further grinding after cement, after grinding of limestone, clinker and gypsum. Then we'll check 27 check. Even on grinding stage, after grinding and before feeding to silo, even discharge, even packing time also we used to collect the samples. Every 1 hour we used to collect the samples. We make an average. We dispatch the test report. That is the report we used to give on in whenever you ask cement sample report. We used to give the test report on cement. So normally you'll get physical and chemical test used to give on test report on whatever cement you supply to you, whatever demand you're asking, we used to give cement test report to you. Right. So total 97 checks we used to do on all our factory on cement, assess the cement quality. There is a myth few of the people are telling I used old cement or concrete is really good. But nowadays with the cement, whatever the cement they're using, I'm not find that much quality. It's actually myth. Even you can imagine whatever olden days used to cement. Nowadays, whatever cement is far better than olden cement. But the construction practice where we were changed. That is because of now it is all the issues are happening in the strength of the concrete, not in strength of cement. We think that it is directly proportional strength of concrete versus cement. I do agree, but the process major involved in strength of concrete than strength of cement. This you can make if you make high grade cement with improper mix ratio, then you'll can't waste. So who is cooking? Based on cooking person, it will be your brownie. Maybe your food will taste the same process. Since we are giving good ingredient, whereas the whomsoever worker, whomsoever the making concrete person, depends upon him. It will change the concrete quality. Right. So quality control for cement and normally we used to surface area or fineness or my blinds fineness. If it is OPC, 270 to 360 meters per kg. If it is PPC or PAC, 340 to 340 kgs. Right. And normal consistency maybe 27 to 31%. Initial setting time it is indicate the rate of hardening, not less than 30 minutes, not more than 10 hours. But we keep initial setting maybe 190 minutes to 120 minutes. Final setting time maybe 180 minutes to 200 minutes for final setting time. We are keeping at in our labor, in our all the cements. Soundness, it is the expansion. We have to find the expansions. It is mainly contributing lime and magnesium oxide. Composition, we used to check 3 days, 7 days, 21 days as per AS norms, whereas we used to check 1 day, 3 days, 7 days to 14 and 21 days, even 28 days. We used to check our cement composition. Why? Because since today we manufacture cement, tomorrow come to our market. So that we want to check the initial strength also on end product. Though it is not mentioned IS norms, but we have to understand what is the strength before we using. And insoluble residue and sulfate and alkali limits all we are and arsenic all we used to take for the quality assessment and cement. This is the test report. These are all the material, all the tests you normally used to get in your test reports. So cement, nothing but clinker and gypsum. It's ordinary Portland clinker and gypsum. And blended cement, nothing but we may add mineral admixtures. Mineral admixture, nothing but fly ash, slag, or rice cask, or maybe metaclinias, or maybe these kind of powder form as we are using as a mineral admixture. We used to have chemical admixtures, that is chemical, is a liquid type. So in cement, we are using only mineral admixture for making cement. Right? It's ordinary Portland cement, clinker and gypsum. Gypsum almost maximum 5%, and Portland cement is clinker, fly ash 15 to 35%, gypsum is 5%, and slag, Portland slag cement and clinker ground blast furnace is 25 to 70%, gypsum is 5%, 3 to maximum 3%, and oil well cement, which is not there in the cement market, but however it is based on the demand. Maybe some few companies are manufacturing. It is clinker is with iron oxide and gypsum. And sulfur is cement, higher percentage of ground slag and clinker and gypsum. Again, white cement, white cement is with a lower percentage of iron oxide with maybe 0.4%. This is the simple mix ratio on cement combination, right? Even if you take an OPC, ordinary Portland cement, which is I have 3 grades, but no more 33. Now we have 43 and 53 in IS 269 2015. And Portland personal cement PPC and 1418 part 1 and PSC cement Portland cement 455 and 2015. And composite cement nowadays are popular in the market. Many people are not understanding whether what is a composite cement in the market, but people, we think that it's PPC, but we are using composite cement only. 16415 is 2015 is a composite cement are available in today market. These are the cements are available for the construction application in today in market. Major is PPC, almost 80 to 90% of PPC. Nowadays, few companies they were used composites also. Now I think one or two companies were used slag cement. I think it's reduced in supply because of production pressure. Cement is cheaper than not able to manage. Then few companies are not able to supply and slag cement. Today, you used to get composite cement and PPC are majorly available in the market, in our market, to construction application, maybe concrete or maybe the plastic mortar applications, right? Just English the banner. So even then you can find the type of cement based on the IS code printed in the cement bag. So see here, if it is any OPC or OPC 43 and 50 grade cement, you could find OPC, it's a IS code black layer. Whenever you go there, you find out the cement bag. If the IS code is black color, that means purely OPC cement. If you find PPC Portland cement, Portland versions, if the IS code is red color. If it is if it is slag cement, it may be orange or maybe orange color. It is called PSC cement, Portland cement. If it is composite cement, IS code white or maybe dark or light blue, the IS code. Based on that, you could find though it is printed on cement by what type of cement. Even then, you could find without reading type of cement, you could find a type of cement based on the ISA mark color. You could easy to identify what type of cement, right? So why concrete preferred? Can we use wood for bleed area? And can we use steel laying of pavement? Can we use asphalt or bitumen for constructive tall maybe building frames? So absolutely no. So that is the reason we use always for concrete. We can with the concrete we can use a dam, a road, or a tall building with the help of concrete. That is why concrete prefer all these construction. So what is concrete? We all know that a mix of coarse and fine aggregate without a chemical mixes, right? So why is it it is called Portland cement? The first cement Joseph Aspen who's invented is a place called Portland in UK. That is called Portland, and cement is nothing. Cement is arrived from Latin word, Latin fish, opus cementerium. That is called cement. So where the cement is invented, first person location place called Portland. That is called we to Portland cement. We are making cement the same type of limestone we using in our India. That is the reason we used to call Portland cement, ordinary Portland or Portland slags, whatever we using Portland based on that same type of limestone we using for making cement. That is why we call this is one. So which is again up to this year almost 20 without air we cannot make any concrete. It's starting from 2 to 8% air must be there in the concrete. Again cement 7 to 15%, and water is 14 to 21%. Sorry, water, and coarse and fine aggregate is 60 to 70% overall by volume. Right. So roll up other material in concrete, fine aggregate to fill the voids, enhance the density and workability, improve the surface finish and stability. There is a purpose. We are adding or mixing fine aggregate in concrete. Whereas coarse aggregate provide a bulk volume, maybe strength, enhance the load bearing capacity, reduce the shrinkage. If you not add a coarse aggregate, it shrink. Whenever you used to get a many complaint on concrete shrinkage cracks. Many of the cases, if you add a proper high volume of coarse aggregate, automatic shrinkage will reduce. Mainly for summer, many of the cases, if you ask any contractor labor, what is the grade of concrete? They said 120 M20 grade of concrete. What is the mix ratio? 1 of 3, even 1 to 3. But if you go and check this market, are they using really 1, 2, 3, 4 mix or 1 out of 3 mix ratio? Many of the cases that almost equal or maybe one pan of from suppose they use 8 pan of coarse aggregate, 7 pan of fine aggregate. That is because of you used to get all this problem of shrinkage cracks, shrinkage issues are coming up in the construction. People are not at all using whatever the ratio required for coarse aggregate, they're not using. Because of that, all these problems nowadays coming up in the concrete structure in normal house construction. right? What is the purpose of adhesion process, or maybe for the workability of concrete and in the fresh concrete. And admixtures is changing property of concrete, maybe workability or adjust the setting or one or two property, changing the property of concrete. That's the purpose we are adding the admixtures. Chemical admixture, like workability or adjust the setting time, or maybe or I said the strength also. Based on the purpose, we are adding the admixtures. Major advantage of concrete, we all know that cost-effective material can make this local available material, can made in any shape and size, and also make a textures and color. And the process of high water resistance structure, you can use maybe drainage dam or tank, and better fire resistance capacity compared to wood and steel, and required a less energy process against steel and rubber, aluminum. So there is a major advantage we are using for making of concrete in our all these construction. What is the what is the function of cement in concrete? Cement is nothing but primarily binding agent. It acts as a glue between aggregates, coarse and fine aggregates, are forming a paste between the concrete. That is the purpose we are using cement in concrete to bonding agent or maybe binding agent or glue purpose we are, and also give the provide strength and durability and fire resistance. That is the purpose we are adding the admixture. We are adding the cement in forming the concrete. That's a major role on cement, right? So what are the advantages? You take an advantages. Cement is a good plasticity in wet condition. In before hardening process, you can make any shape and size with the textures, colors with the help of cement, and also strong bond between steel and aggregates, and also its high compressive strength, good durable, and also high fire resistance capacity. And also it is economic. It is can compared to volume of coarse aggregate other material is economic on volume. Even if you take a volume, so imagine what is the amount of coarse fine aggregate added or coarse aggregate added. If you add this much, it's too costly. So it will less amount of cement will give economical and give the effectiveness. And also it is a more flexible. You can meet this engineering property, whatever requirement you want, you can make with the help of cement. So disadvantages, mainly low strength. That is wherever the tensile strength is the very it is a disadvantage. That is the reason we are adding the maybe fiber or maybe steel for the in the concrete or maybe steel applications in the construction purpose. The same cement as the weight also and volume also high. So that is a bigger disadvantage, and also major disadvantage is a more shrinkage. It will shrink if you are not cured properly. It will be a shrinkage. Because of that, its quality fluctuation is prone to crack, or maybe the honeycombs. All the problem will come because of the shrinkage of cement. Right. So role of cement, the binding agents is key ingredient binding with the cement and component other material, and strength and durability because of adhesive process with the water and cement will give the strength as well as the durability of concrete in this structure. What is the structure? And versatile, you can make any shape and size of the member with the help of cement. And the foundation of the structure, it is essential to build a foundation, wall, floor, all these applications we can use this material. And infrastructure, the critical construction, the road and bridge, wall, these order of construction, you can use with the help of cement. Cost effective, it is affordable and reliable, uh, readily available in large scale projects, even for whatever large scale, any projects are available. And energy durability, cement structures resist the weathering and corrosion and degradation and reducing the maintenance. And compared to steel and other material, the maintenance cost is very, very cheaper, right? So whenever mixed with water, it hydration takes place. Whenever mixed with cement and water, the first hydration takes place. Calcium silicate will give CH gel binder components. The balance is calcium hydroxide. So when you add this slag or phase, again what the calcium acid react with one more time will give double actions. Again will give the calcium silicate hydrate. That is the advantage for comparison of OPC and PPC for the construction applications. There are four major component on cement and clinker. There is a bogies component or allied belide compound. We used to call it as four components. There is a C3A and C3S and C2S and C4AF. That is what tricalcium aluminate and tetracalcium silicate, dicalcium silicate, and tetracalcium alumina ferrate. These are the four major components cement. If you take an example, C3A, it is contribute to setting time and the process of high heat of hydrogen. This is a major disadvantage in too much of C3A. And again C3S, it is a contribute early strength and also it more heat. Wherever the red flag mark, it is a danger for in concrete or maybe cement. Again, if you take an OPC, these two are high. C3A and C3S are high, whereas come to the blended cement, C2S more compared to OPC. So that is the reason you will give the more durable in blended cement compared to OPC. It contribute less strength, initial strength, and produce a low heat of addition. It will give you the highest strength later stage. And tricalcium aluminum fluoride, it's no significant impact in cement, but it's majorly from um, majorly it's from gypsum. It will sometime more amount of C4AF. It will affect the workability of concrete. It will majorly for slump retention will affect the C4AF. So this is the range. If you want to take photo, you can take for academic purpose. So I know I don't want to read all the things since time is going on. So I'm just speed up the session. Right? I don't want to go again. Just skipping. If you take an example, anytime you mixed with water, the hydration takes place. After completely hydration, it almost there is a volume is twice. Whatever the size story is, for example, 1 mm, for a simple understanding purpose. After hydration, it will maybe 2 mm, double the size volume will increase. When there is a gel forest, almost 0.28 into size of original like say original cement particle, right? So this is what volume. Because of that, it is gaining the strength in concrete. So if you take an example, this is the an unhydrated cement. Then maybe 3-4 days initial hydration, then completely hydration of cement process. This is the way strength gaining in cement and concrete or mortar applications. So whatever this needle type of there, it will hold these aggregates. If it is more and more old, then bonding capacity will increase in concrete or plastic. Whenever mixed with water, whenever cement mixed with water, then initially it give the more heat. See the graph. There are 4 stages. The 4 stage, first stage, when mixed with water, that immediately heat up takes place, that heat evaluate. Oh, take a simple example. You take whenever the limestone, if you add more water, the immediately heat will evaporate. The same way, since cement is manufactured with the help of in limestone, same way it also when we mixed with water, it immediately takes place heat. So it may be maybe within 10 few minutes. Then after that, where this stage two is the workable nature. We want to do whatever the work, maybe plastering, concrete, brick, or all you do within maximum 2 hours or 3 hours time. You have to complete the all the job. After that, maybe 2 hours, the initial strength setting and strength will develop. Then after initial setting done, then after they'll go for the strength property. Then slowly the heat will reduce. Then it will neutralize. This is the phase 3 phases. Like first phase initial mixing reaction. Phase is dormant, that is silent, that is maybe sleeping stage. In sleeping stage, we used to do all the work. Then phase 3 is the strength and acceleration, and phase 3 is speed up the speed reduction. After 4 is slowly reduce the heat of operation. Then phase 3 is steady development. That means that then is a service time. There's a time of concrete will give service applications. This is the way cement performing in concrete. I'll go for further in detail. You could understand this slide. The stage one, when you mixed with water and aggregates, maybe in concrete, it'll give liberates heat. There's a hydration takes place. It may be maybe 2-3 minutes, or you have mentioned 15 minutes, but over 3 to 3 minutes it will give the heat. Then is a dormancy, the stage two. It whatever work you want to do, plastering or brickwork or maybe concrete, you have to complete this time. That is before initial setting. That is the reason when you mix it with water, all the work should complete before initial setting. Normally you take a cement, initial setting time maybe 90 minutes to 120 minutes. When you mix it with water, that work has to complete before 2 hours. That is the we are advising all these workers or maybe engineers in the field, try to complete all the work within the stipulated time, maybe 2 hours or 1.5 hours. You have to complete the work. After that, vents should not be disturbed when the initial setting to final setting time. If you disturb, again you want to add more amount of cement, I will be a maybe delaying strength, I will give you low strength. So it is actually then after the final setting, you give the strength giving the process. This is the way you have to get, right? Right? So if I take an example, I'll give this simple example. This is the process I already informed. This is a dry cement. Then it's after that, after gaining the strength. But take an example, microscope structure. There are four corner. There are four cement particle. In between, there is a voids. In the voids covered with water. Right. When we contact with the cement, then automatically gel combination will develop. See here. Sorry, right? So it is already unleaded cement will be a dry cement, then mixed with water, that is takes place, further giving the strength. You take an example here, there are given horizontally in row wise, there is high water cement ratio. Add high amount of water cement, there is a cement particle too far of each other. Whereas the bonding develops maybe 3 to 4 days, further maybe 28 days, it may be closed but too far away. Whereas low water cement ratio, closer cement particle close each other, then automatically the bonding properties increase. Whenever making concrete or mortar, you try to avoid more amount of water. Because of that, you will gaining the strength. We all know that higher water cement ratio, low water cement, low in strength. That is the reason more and more water is occupy the more porous than the cement particle too far away. That is the reason we will get losing the strength. Whereas low water cement is giving a higher strength on concrete. So this is the way actually which I talked about. These are four corner of cement particle hydrated. Then gel force there may be capillary force built and uh, gel for this one. What is it called? Because of that is a needle, a crystalline particle bonding the each other cement particle along with the aggregates. So if you take an example, this is the white color. This is take an aggregate. In between aggregate and cement phase called a transition zone. The cement phase has to give the most strength. You see, this is called how much is cement particle close to the coarse aggregate, you give the highest strength on concrete or mortar, right? So I think it's completely understood everyone, right? Right. This is the initial interfacial zone, maybe transition zone, right? So I don't want to go on too much in all these theories. Just I'm skipping. Almost we are discussed. But nowadays, today in Coimbatore in Tamil Nadu, we launched ACC Gold for water repellent cement. For the wherever dampness, you can use the cement. I'll just give a video for understanding. In maybe future, I'll give the detailed presentation on the cement. What is the advantage and disadvantage? What is the advantage importance? But I'll give you the simple example. First one is normal cement, whatever nowadays you're using gray cement. And second cup of cement is maybe ACC Gold. Today are available in Coimbatore, Erode, Namakkal, Salem, and all these market are available this kind of cement. Just to play the cement video. See, this is the first one is gray cement, just immersed in water. Again, I'm just keeping for ACC Gold inside the water, just immersing both the cement. Whereas wherever the whites in the whites, the water is going inside. Whereas gold, there is even though whites is there, but the water not allowing inside on the concrete inside the cement. Easy to understand. Yeah, can you explain this? Okay. Just have a look, sir. Just take this one. No, just listen. So, just an I think it's easy to understand everyone. See that wherever the air bubbles is there, water is going inside. Just 1 minute keeping inside and just right. So just I'm keeping and just moving that. Just I'm taking out from the water after minutes. Just whatever the cement is fully it's like immersed in water. Whereas I'm taking out ACC Gold from the water after a minute. Just see that. See here, there is no water gone inside. So these are water repellent cements are available in the market. It is act as a water repellent in the concrete surface. Just see that after making concrete, this is the just spraying water. You could see it's like how the lotus leaf lays the water like that. It's like a bubbled, right? Even you see that plastic stage, it is though water is curing, water is on the surface on wet condition, but water is not penetrate inside the plaster. Whenever the rain come, it won't go inside. This is the advantage of the cement, right? So we may discuss in future and detailed discussion. So these cements are available in the market. Thank you so much. And any few questions you'll answer for it, or else we'll wind up the session. So any doubt, any clarification required, I'll be happy to answer for it. So I think nobody has doubt. Thank you so much. Karthik sir, are you there? Karthik sir?
Some messages come up, sir. So nice presentation. I have one doubt how to cure that. Okay, so some question is there, sir. So
Tell me, sir.
at least one guy has asked some question.
Yeah, tell me, sir.
You can
tell me,
answer
sir. What is
it.
the question? What is the question,
I
sir?
have one doubt, sir. How to cure that? What to cure?
Sir,
So
what is the purpose of curing? You should understand. Purpose of curing, it is water should not away from the concrete. Normally, we used to cure the concrete on top surface, whereas we are not curing on bottom of slab or maybe beam. So wherever the water losses, we want to keep wet condition. If you want to cure upon curing, you don't have any problem. Even though you place the water, water retain on the surface, it may not go inside. People are think that concrete drinking the water. That means there is too much of voids in concrete. Okay, any concrete, if it is drinking the water, that means your concrete very improper concrete. It will keep the surface wet, but may not go inside. Even if you take an example, our body, there is a porous in even our body, so sweating is coming out. Whereas we take a bath, there is a water wetness, but water cannot go inside. Same way, concrete, whenever concrete or plaster application, you pour the water, it will be keep wetting, wet condition, it will not go inside. Right? I hope this is clear.
yes,
Sir, I am Professor Ilongo.
Yes, sir.
The normal question nowadays, the students are doing many projects for alternate material, especially they are
Okay.
reducing the cement content. They are
Yeah.
introducing so many alternate materials, byproduct
Yes.
materials.
Mm-hmm.
So, but the code so far doesn't say that the byproduct, it will be 10, 20%, 30%. This is the level or other things. But
Okay.
they are comparing the 100% of cement, because the most of the code for IS code, they recommended only for whatever the test result indicate, you have to compare only 100% of cement. But these students, they are comparing they are using only 80% or 70% cement, they are comparing. How it will be justified, sir? Whether it will be correct or not?
Sir, first you have to think what is the purpose they're using. It is concrete. If you get whatever the control to mix, if you achieve the strength of M20, M30, we don't have any problem. You can optimize. So based on the purpose applications, what type of application we are using.
Suppose if you are using some beam or column, especially the massive structures, for example, retaining wall and other things, simply if you are reaching the target strength, it is advisable to use the alternate material. For example, plastics or bagasse or they use it for slurry. So that type of.
Not only strength, sir, we have to check other property, shrinkage property, or maybe just a minute, sir. Just a minute, sir. It is mainly depends upon other property we have to check. What is the other property, chemical composition, maybe durability aspects you have to check. If you are not checking, then not only strength alone will not give the quality of concrete or grade of concrete. So you have to check other aspects also.
Any other options that nowadays they are talking about carbon emission because of cement industry. Most of the carbon emissions will be there. We are not able to control the carbon.
Actually,
So
carbon, sir, now
this
understood. Understood, sir. Since carbon, you're talking about carbon emission, but in cement industry, we can instead of going OPC, we are going for blended cement, we go for high volume of layer. And also, we are going for the what is it called? Clinker factor we want to reduce. And also actually this entire subject we're going to talk full section on. But I'm telling nowadays we are using the we are not making too much of OPC cement. That is the reason we are why you want to go for OPC? They're going to early strength, high setting. So even then blended cement itself nowadays we are developing the with almost 20 to 30% fly ash we can making with the OPC strength. One thing, and also in construction practice, many of the people are using on grade of concrete by volume batches. You have to adapt for mixed design. You have to optimize the cementitious content with the help of high volume. And also we are targeting only 20 days. We may go for a year and future for instead of 20 days, we go for 30 days, 40 days, 50 days or 60 days strength with a high volume of mineral admixtures, right? And apart from that, go for higher grade of concrete, we can reduce the size of element. That are the possibilities there.
Oh. Sir, one question from chat box. That is our one of the professor, Dr. Jagannathan, asking this question.
Yes, sir.
Can you tell us about net zero concrete? Is Adani working on it? Net zero concrete. Is Adani working on it?
Sir, it is in the process, sir. We think we have to get in detail in from our R&D section. It may working. Even we are working on more and more low carbon concrete, sir. Since we are binding material, we want to go with cement only time being. Since we are doing with cement manufacturers, but we want to go for low carbon or low carbon emission, we are working on it, sir, currently.
Okay. So that is the question they asked from chat box.
Yes. Thank you, sir. I think I have some.
Next one is common question. PPC and OPC cement, where it is used. That is everybody's
it is not. My advice, please don't use OPC any of the construction other than RCC. If you want to go for this one, what is it called? RCP, this one, PT slab, maybe you go OPC, they want early strength. Or else even you go for the PPC also with the help of accelerator, you can use for the early strength. If you use OPC, the natural waste actually, if you want to take OPC, 1 ton of OPC, almost 1.5 ton of limestone required, almost 1 ton of carbon dioxide emission to the atmosphere. This is a major culprit on consuming the natural resources as well as the carbon dioxide emission. Whereas you go for blended cement, you can go most welcome even as a manufacturer, as a civil engineer. We have to look for the blended cement only for the construction application. And moreover, we are not targeting OPC for our design. We are targeting a grade of concrete, a grade of steel. So even you can make with the PPC with a high grade of concrete. Even today, if you want to make any high grade, even M60, 50, without mineral admixture, you cannot make any high grade concrete. So better you go for PPC only, sir. Not blended cement.
Okay, sir. That's all the questions. If any
thank
questions
you, sir.
from
Actually, I'm just thank you, sir. I'm just log up. I'm lined up one more meeting. People are waiting. Sorry for this interview.
Okay, sir. Thank you, sir. Thank you.
Okay, sir. I'll thank. Okay, so thank you so much for the speaker. So because the name itself, it gives us இளமுருகு தென்றல். ஸோ அழகு மற்றும் தென்றலாய் வந்து ஒரு அழகான ஒரு லெக்சரை கொடுத்ததுக்கு மிகப்பெரிய நன்றிகள். அவர் இல்லைனாலும் அவர் சார்பில் நம்ம சொல்லினா என்ன, I could see the more number of participants and we could also see the number of participants who have raised the questions. So that itself says that his credibility. So thank you so much for the opportunity. The IE also takes the pride in congratulating the initiative. So especially the Karthi sir, so who has taken this initiative in making this event more successful. So more such events are about to follow. So the students and the participants, the scholars as well as the people who have joined here today. So they might have a continuity of the services by subscribing our channel. So there is a WhatsApp channel which is available. You can have a notice of each and everything. So every week there is a meeting that is going around, which might be a helpful process for you to go through. And we just wanted to have your connectivity in making sure that the industry and the academic is being bridged with this sort of lecture meetings and workshop. See, we want the people to be the active participants. So that is a very good approach for each and every individual in enhancing your engineering skills. 100 years institutions takes the pride in thanking the committee members, the council members, and the organizing team for making a wonderful event. We will catch up with much more meetings thereafter. Thank you so much for your time. Thank you, everyone. Thank you. So
Thank
I
you.
need to thank
Yeah.
personally our chairman, so who is also a civil engineer, so who has got such a rich experience in giving such lectures. So I thank our chairman as well as our committee member for making the event more successful. Thank you. Thank you.
Thank you,
Yes, sir.
Secretary
So
sir,
you
and
are about to say,
for giving me the opportunity, sir. Thank you.
yes, sir. Thank you. Thank you. Radhi madam, so you can just close the live session, and you can also close the meeting. So in case nothing is there to discuss about. Thank you.